You guys can try to mute your mic so that what I'm saying can flow. Okay. All right. So I have one mobile phone before me today. So which is x657. Okay. So this one is from a technician. It's from another workshop. Okay. So the phone, according to the complaint, the phone is charging, but it's not increasing. So that's the complaint. So now let's try to check. So now I'm going to plug the charger along with the USB meter. Okay, so this is the USB meter. So let me plug the battery.
Before.
Mr. Thompson, Mr. Paul, mute your mic, please. All right, so now, so I will plug the charger. So first of all, it's indicating that it's charging. Okay, and you can see it's displaying that it's charging. But the issue is that it's not increasing. You can see. Let me try to power it on. All right, so the phone has power on. Okay, actually, okay, the battery has low, so it can't withstand the. Okay, so just for the clarity, to clear the condition, so I check whether the phone is powered on or not. So it's powering on and it's charging. Okay, now the phone is charging. You can see 1%. But now, observe one thing in the current meter. It's not taking any current. The phone is charging but not taking any current. Are you all with me? All right, so it's charging but not taking the current. So this means that there's a problem. The phone will not increase. Now, in this case, what could be the problem? Can anyone share any idea? Before we proceed, how can we troubleshoot this fault? So how can we troubleshoot this fault? No one is answering me.
So which phone is this one, Joe?
This x657. That's Infinix.
In my own idea, I think that okay. In my own opinion, maybe we can change the
You said? I don't hear
said in
you,
my own
Mr.
opinion, maybe and
Your voice is not clear.
let
No, I'm hearing you.
me use my output. Let me know. Hmm?
It's not clear.
Can you hear me now, sir?
Now I'm hearing you. I'm hearing you. I'm
I
with
said
you,
in my
Mr. Adams.
own opinion, okay, my own opinion, maybe
Okay.
because by force issue.
I don't hear you very well. That thing is your voice is galloping.
Let me turn my
Hello,
iPod
sir.
because
Can
I'm
you hear me,
laughing.
sir?
Yeah,
When I
I'm
can
with
come.
you. I'm with you. I can hear Mr. Vincent clearly.
Hey, check this down, boss. They don't bring lights now. Tell them they don't bring lights. Yes, sir. Hello, sir. Can you hear me, sir?
Yeah, I'm with you. So
Uh-huh. Sir,
what is your own
I saw
opinion?
one of your I saw one of your video on TikTok, sir. You did this kind of a problem.
Okay,
So
sir.
I can share from what I got from your video, sir.
Okay, good.
Okay, sir. Sir,
Yeah.
first of all, you shared the on hot testing, the VBOS. You said yeah, the that guy you drew for us before you worked on the phone. You said on the VBOS we should be having our 5 volts coming to the VBOS. That's
Okay.
the leg of the charging port.
It's okay.
Then if we get the 5 volts, then to confirm that the charging IC is okay, we should have our 4.2 volts on the VBAT,
Okay.
the positive leg of the battery terminal.
Yeah.
When the charger is being plugged, we should have 4.2 volts.
Okay. So where are we going to start on this case?
Video we got the 4.2 volts, and
Yeah.
it was not increasing.
Okay.
Then you said it should be the DM and DP. You said it should be the DM, the data minus and data plus on that phone.
Hmm.
So what he did there was you changed a resistor or something like that to get
Okay.
the actual value of that data minus and data plus. Before it
Recording
started
in
working.
progress.
Okay.
Don't take this remote light back.
I'm hearing Mr. Vincent. So now, on
Yes,
this
sir.
case now, where are we
So,
going to start the troubleshooting?
Kama line record data ijja kugura.
sir, let's see if we are getting our 4.2 volts on the VBAT.
Okay. Now, let's start. So let's follow Mr. Vincent.
No, sir,
Right?
it is you we are following. No, it's what I learned from your TikTok. Oh.
Attention.
Why now?
Hello,
Are you not
really
confident in what
mission.
you said? Be confident now.
Yes, sir, I'm confident in what I saw you did, sir.
But now, maybe I should recall. Where's the charger? In that case on the TikTok is different from the from this case. Hope you can see my USB meter.
Yes, sir.
Now, I want to plug the charger. So I plug the charger. Let's observe. So it's charging. We have 1%, but it is not taking ampere. So the condition that this engineer brought it is that it's charging but not increasing. So where are we going to start? I want us to reason
Start
together.
start from the charging point itself.
Okay, what are we going to check on charge ports?
Whether all those legs, all those 5 pins, if they are connected properly, sir.
Any other idea? Or we should stick on Mr. Vincent's idea?
We want to check the voltage before.
Okay. Okay. Which voltage?
5.
You said
The bus line.
P bus line. Okay, Mr. Vincent. Mr. Vincent.
Yes, sir. When I sign of God, the God on the cup.
So let's start from P bus. What you said is right, but it is the checking of the P bus that would let us know uh will let us know the will let us know let us what can I say, to suspect our charge port. I'm coming. I want to adjust my microscope. So there is a test point here for P bus.
Now for the SB power flex.
So there's a test point here.
Now give me
So
SB power flex.
so this is a test point for P bus. If I'm right. Okay. So let me plug back the flex and insert the charger again. Okay.
I don't know.
So let me check. So I'm going to insert the charger and check for the fibers. Now let's check. Hope you can see my multimeter.
No.
Can you see my multimeter?
No.
No, sir. No, sir.
Now were you able to see it now?
alinda enzija bagamba bangi
Now let's check for the
oba
fibers.
oli
So we have our fibers.
wajja
Everyone, can you see it?
Yes, correctly.
So that's
Yes, I
correct.
can see your millimeter, sir.
All right, so that's correct. So this means that the voltage is getting to the board. Now, what is the second thing to check? What is the second thing to check?
But
Sir, check if the voltage is going to the V-band.
So feedbacks. Thank you. And the fastest place to check the feedbacks that will be on our battery terminal. Okay.
yes.
So we are going to check from here. These are positive terminals. So now let's check. So I did not remove the charger. So now let's check.
Okay.
What do we have?
We have 1589.
1.5 volts, 1.6 volts.
We have 1.6 volts at feedback. Is that correct?
No?
How much voltage are we expecting in feedback?
3.2.
To 4.2, 3.7 volts to 4.2, but we are having 1.6.
Incorrect.
That's incorrect.
Sir, if you have 3.7, is it okay? Is it okay if you have 3.7?
What happens is that actually, uh, for the voltage to charge the battery, you have up to 4 volts to 4.2. But we are just keeping it, assuming that at least maximum voltage, because for it to charge, you must have up to 4 volts to charge the battery. But the voltage that the battery will give out to power the phone is in between 3.7 voltage to 4.2. So if it's not up to 3.7 volts, the phone will not power. Okay.
Yes.
All right. So now we have 1.6 volts in our feedback. What could be the problem? What can we suspect? What can we suspect? Actually, let me open the schematics of this mobile phone. Mr. Vincent, I have checked that diode on that schematics.
Okay, sir. Yeah.
So it's
Thank you,
a
sir.
big system, it's a big system. Try to change that diode, replace it.
The diode, can you affect the display?
Change it. Give it another one.
Okay, sir.
Yeah.
Okay, sir. Okay, sir. Thank you.
And do you remember how it's
Not every
connected?
night.
Okay, you can check on your schematics to know the connection.
Yes, sir. Yes, sir. The place marked is the V
All right, all
bar.
right,
The other side is the V system.
all right. So replace it. So this mobile phone is x657B. Okay. So the board number is H8030. So that mobile phone, this meaning Infinix Smart 5 is up to say 2. So the board number we have the one that is H that's H6117. So the one I'm working on is H8030. So let me open the schematics. So this is the charging section. Now they are using transistor. So it's a transistor charging section. But in this case, they are using single transistor, yes, single transistor. Okay, so this is our base, which is what? That's P drive. So P drive, that's the voltage coming from the power IC to switch this transistor. And our emitter, that's the 5 volts coming from the charger. Okay, so it's connected to this P bus. So we're coming to this. So this means that we're supposed to have 5 volts here. Am I correct?
Yes.
We also to have we're supposed to have a drive voltage. That's P drive voltage. That's 2.7 2.8 volts maximum. Okay. Okay, yeah, maximum 2.8 voltage coming from the power IC. So it is power IC that is controlling this section. But I have faced some issue like that, whereby I have faced some case like that, whereby you are going to see like up to 4.2 volts. I don't know how they do that. But if you remove this, this guy and check again the voltage that is coming from the power IC, you can still see like maybe 2.3 volts. So, but when you connect it back again, the drive voltage will be 4.2 volts. So they are the one that know that how they do that logic. But notwithstanding, you must have a voltage to drive this transistor coming from the power IC. But now, for our collector, which is our feedback, is giving us 1.6 volts, right? So it means that the voltage is not enough. So what could be the problem?
Yes, sir. Yes, sir.
What could be the problem? And we have checked our 5 volts on the board. The 5 volt is not reducing, it's enough. It is accurate. So guys, what do you think? Now, you know what? Let's try to check 5 volts here. Let's see whether the 5 volt is present here and is accurate. Okay. My camera, I don't connect a lot of camera with my system, so I'll try to be switching, showing you understand. So let's look at the transistor. So now this is the transistor. That's 2530p. Okay. So we have to look for 5 volts. Yeah, this is our emitter. This is our emitter coming. This is our emitter. That's input. So we have to have we must have the 5 volts here. We must have the drive voltage. So this is our base. So that's the control switch. So all this is like they are collector, which is working for feedback and going to the charging connector. Now, let me try to check. So I will switch my camera back because you will not see my multimeter if I'm trying to check. I'm not hearing your voice. Your voice is galloping. So as if you want to talk, Mr. Pleasant.
I cannot see it though.
You said? Are we back?
Sir.
You said? So why did I stop? Because I see that the network have cut off. So I want to know where we stop so that we can relate it together.
Sir, you were trying to show us the transistor on the board.
All right, so let me back to it. Now this is the transistor. Hope you can see it now. Can you see it? Good. That network is fine. Are we back? Mr. Vincent.
Sir.
Okay. So I want to know whether the network is balanced. If that network is not balanced, please always indicate. Okay. Now this is the transistor. Hope you can all see it. Can you all see it?
Yes, sir.
So that's the transistor. So this is the emitter. This is the emitter. This is the collector. This is the collector. And this is the.
Sir, we cannot see what you are pointing, sir. Sir, we cannot see what you are pointing.
Can you not see now? Can you see? Can you see what I'm touching?
Yes, I can see now. Yes, sir.
This is the transistor that we see on schematics. Okay. Mr. Azan, are you hearing me? I don't think Mr. The network is not good in the side of Mr. Vincent. All right. So, Mr. Vincent, are you active? Because I don't want you to run off back. Are you active now?
Yes, sir.
Okay. So now you can see what I'm touching, right? Mr. Azan, unmute your mic. So definitely you are hearing me, right?
Yes, I hear you.
All right. So
See,
hope
this people.
you can see what I'm touching.
Yes.
Okay. So according to what we see, what we saw on schematics, so this our emitter, that's the input. So this our collector, and this our base. So that's the control pin from the power IC. So now we must have our 5 volts here for the emitter. So we must have 5 volts here. So for the base, that's the P drive. So we must have a control voltage here, and also all these legs are working for collector, which is pivot. Now let me check on schematics one after the other. So let's check. Now I'm going to check the 5 volts on that pin of that charging IC. the charging MOSFET. I mean, so let me check if I have a 5 volts. So focus on my multimeter. Now the 5 volt is present. So the 5 volt is getting to the input of that MOSFET. All right. So now for the control, that's the base. I have 4.2. I have told you that when you connected the MOSFET, you have you're supposed to have like 2.8 volts, but they are the one that know they know how they do the architecture. Okay, so we have so this means that the control signal, the control voltage, that's the feed drive is coming, so which is 4.2. That's 4.2. So that's 4.2.
I never gone that name.
Okay.
So we cannot see what we are.
All right. So now the output of the charging IC, now charging MOSFET, I mean, is now what 1.6 voltage, which is coming to the battery connector also. That's 1.6 also. So whereby the charge MOSFET is supposed to give us the output of 4.2 volts to charge the battery. So now I just want to share my experience with this. I have solved many cases like this. So now it's not charging. It's not charging, and it's taking a good amps now. Let's see. So that's 0.8 amps. So we left it as 36%. Now it's 37. So it's now increased. So once it's taking amps, it will increase. Hope you understand. So yes, the first case is that it's not taking any amps at all.